solving equations by graphing and square roots. Okay, so we're going to first talk about graphing quadratics. When graphed, a quadratic makes a parabola, that's a U-shaped graph, and the solutions to a quadratic when graphed are on the x-intercept. You could have 1, 2, or no solutions to a quadratic. So here we have 3 different parabolas, so 3 different graphed quadratics, and we're looking for the solutions here. So first of all, we need to identify the x-axis, which on the first one is right here, and we just need to see where our graph crosses the x-axis. So we cross here and here. So our solutions, and be careful on this graph because it looks like it actually goes by 2's, so 2, 4, 6, 8, 10. So our first solution on the right would be the point 2, 0, and then on the left we have the point negative 2, 4, 6, negative 6, 0. So those are the solutions to our quadratic. For the middle problem, our x-axis is right here. Since we don't cross the x-axis at all, that means that there are no solutions. And for the third one, we only touch the x-axis at one spot, which happens to be at the origin. So this would have one solution, which would be 0, 0. So again, you could have 2 solutions, no solution, or 1 solution. Okay, next we're going to talk about solving quadratics using square roots. So we'll get into some more solving quadratics in the next concept, but anytime we have quadratics where, for the first example, see how we only have an x squared and there's no other x, or this example, we also have an x squared with no other x, or we have a quantity squared like this problem, then we can use square roots. So looking at this first problem, our goal is to get x squared by itself. So it looks like I have a negative 9 with the x squared on the left side. So I'm going to move 9 over by adding it since it was negative. And I get x squared equals 9. Then, now that I have x squared completely alone, I can take the square root of both sides, and I get x equals 3. But there's something a little different here. We need to put plus minus 3. All that means is positive and negative 3. So you can really write it either way, however you prefer. So let's talk a little bit why it might be positive and negative 3. So with this means whatever x is, if we square it, we get out 9. So if we were to put 3 in there, we can all agree that 3 squared is 9, so that works out. If we were to put negative 3 in for x, negative 3 times negative 3 is also 9. So with quadratics, a lot of times we have 2 solutions, and in this case, it's positive and negative 3. Okay, next problem to the right here. We're going to start by getting the x plus 3 squared alone. So we're getting whatever squared by itself. So I need to get rid of the 2 out front. Going to divide both sides by 2. I get x plus 3 quantity squared equals 16. Now that I have the squared part alone, I can take the square root. Squares and square roots are inverse operations, so that's why these just cancel out, and we get x plus 3 equals plus or minus 4. Remember, anytime we're taking a square root here, we're going to end up with a positive or a negative. So again, let me rephrase. I got the quantity x plus 3 squared alone, so I got rid of that 2. Then I was able to take the square root. Square roots and squares cancel out, so I crossed those off. And I have x plus 3 equals 4. Now we're going to need to break this into 2 different equations. One equation will be x plus 3 equals 4. The other equation will be x plus 3 equals negative 4. So I'm taking this number right here and I'm writing it once as a positive, once as a negative. Now if I solve these, subtracting 3 over, I get x equals 1, and I get x equals negative 7 as my 2 solutions. One way that you can check yourself is by plugging these numbers back in. As you can see here in the purple, I've checked the solution x equals 1. So I plugged 1 into my equation where x would be, and I confirmed that I got 32 equals 32. You would also need to check -7 as well independently. Okay, and on our last problem, we're looking to get x squared alone. So the first thing I'm going to do is move away whatever is added or subtracted on. So I'm going to start with this 31. I'm going to add it over. So we get 4x squared equals 80. Then I'm going to divide away the 4. I'm going to get x squared equals 20. Now a common mistake is people might stop right here on this line and take the square root. We can't take the square root until the x squared is alone, so make sure you get rid of the 4 first. Okay, now that we have x squared equals 20, we can go ahead and take the square root. So we get x equals plus or minus the square root of 20. Now recall, whenever we're simplifying square roots, we need to find the largest perfect square that divides 20. So my perfect squares are 1, 4, 9, 16, 25. Okay, so since I've gone over 20, I know that one of those is going to be what I'm going to use, and that would be 4, because it divides 20. So break this up into the square root of 4 times the square root of 5, because 4 times 5 is 20. And the square root of 4 is 2, so we get x equals plus minus 2 square root 5 for our answer. For the next problem, we're going to start by taking the square root of each side. So we get x minus 1 equals plus minus square root of 13. And then next, all I need to do to get x alone is to move that 1 over. So instead of writing this twice, once set equal to a positive square root 13 and once set equal to a negative square root 13, I'm just going to add that 1 over and leave the plus minus square root 13 like it is. The reason I'm doing that is because I know I can't combine 1 plus square root 13 or 1 minus square root 13, so I'm just going to write it in this more simplified way. I still have 2 answers. I'm just writing it as 1. Now we're going to do the independent practice part of the notes. So what I want you to do here is I want you to pause your video and work out the 3 problems for independent practice, and then restart your video and check your answers with me and listen to me explain the problem if you didn't get the right answer. For the first problem, I started by subtracting the 14 over, dividing by 2/3, and then taking the square root of both sides, and I got a positive and negative 3. For the second problem, I subtracted my 1 over, and then divided by negative 2. I want to leave my answer at this point as 7 over 2, 7 halves, just because whenever we take a square root, we don't want a decimal inside of the square root, so don't change that to 3.5. Next, I square rooted both sides, and I got a plus minus square root 14 over 2. Now, you may be wondering where I got this 14 from. Remember that we have to rationalize anytime we have a radical in the denominator, which we technically did whenever we had the square root of 7 over 2. So rationalizing, I'm going to take and put the square root on the 7 and the 2. So square root 7 divided by square root 2. Multiply the top and the bottom by the denominator, which in this case is that square root 2. I did that in green. And then in the end, for the numerator, I get square root 14, and on the bottom, I just get 2. For the last problem, I started by square rooting both sides. And then again, since I just have a plus minus square root 3 on the right side, I can just take the 2 that's on the left and subtract it over and put it out front. I don't need to write this as 2 separate problems because I know that I can't combine a 2 and a square root 3.